What up, mathletes? It is the Math 2 Module 11 review. Let's get into this. All right, good stuff right here. It says, what is the degree and leading coefficient of? Well, when I look at it, first of all, I'm looking for the highest valued exponent. And that also means, by the way, if there's multiple exponents. So if I had like 3b squared q8 z9, I would add all these together and I would get what, 17, 18, 19? So that'd be a 19th degree, right? Okay, just so you understand that, we don't have that here, but I want to make sure you know if there's ever more than one variable, you add the exponents together when they're in one term. But nevertheless, looking here, this one's a bit easier. We have 6, 8, 1, even though we don't see it in 5, so clearly it's the 8. Let's circle the whole thing. So the degree is, it's an 8th degree polynomial. What's the leading coefficient? That's that number in front of the variable, which is -9. Super simple right there. Okay, I'm going to walk you through how I simplify stuff. This is the work I would expect to be shown to receive full credit. I'm going to distribute this negative, okay? So it's just going to be -7t squared plus 3t minus 6. And then I'm just going to combine it. 4t squared minus 7t squared is -3t squared. And then I have no other t, so plus 3t, plus 3t. And then I have plus 2 and minus 6, which is -4. And that is a fully simplified and put in descending order of powers polynomial. Okay, or trinomial. It's polynomial, but it's a trinomial, right? All right, now we're going to rewrite this without parentheses, which just means we're going to distribute it, guys. Let's distribute it. Now you got to remember that negative. Please don't forget the negatives, guys. I see that happen all the time. -8 times 4 is -32. X to the 4th times x to the 3rd. I'm going to add those, right? So that's going to be x to the 7th. And then I'm going to have -8 times -8 is plus 64. X to the 4th times x to the 1th, I'm going to have 4 plus 1, which is x to the 5th. And then a negative times a negative is another positive. -8, or 8 times 2 is 16. And then no x's, so just x to the 4th. Boosh, right there. Look at that. Let's look at this. We can multiply it out. Oh, guys, I'm going to do some of these twice just to show you so you can see it's true. But this is a difference in squares. Whenever you see w minus 6, w plus 6, the same number, it'd be like they're a square, right? Except it's a minus and a plus. This is just going to be w squared minus 36, right? It's a squared minus b squared. But if you want to see it worked out, I will do that. W minus 6, w plus 6, right? W squared minus 6w. This is why the middle cancels out, because then it's going to be positive 6w, so those are going to cancel out, right? And then the last term is -36. That's why this works, okay? But difference in squares is really nice when you see it. Okay. Right here, v plus 1 times v minus 2. Well, we're going to have to, you need to foil it, first outer inner last. I like generic rectangles. Clearly, I've made my position known on that. v1, v -2. Let's just do it. V squared. 1 times v is v. V times -2, -2v, and -2. Remember, the squared diagonal is always first and last. V squared and -2. The other diagonal will add 1v minus 2v is -v. I know it's kind of spread out, but there we go. V squared minus v minus 2. Oh, I love this. Don't forget, what is this? And it's a minus. We got to know that. So this is going to end up being, right? If I have a minus b squared, that equals a squared minus 2ab plus b squared. So, again, I'm just going to square these. I know my first term is going to be 6 squared. My last term is going to be v squared, and it's going to have a plus right there. And we're going to have a minus here. And my middle term is going to be 2 times 6 times v, which is 12v. And I probably should organize this. So this would ultimately be v squared minus 12v, right? Because we've got to take that minus with it. And then that's a positive 6 squared, so plus 36. See how I organized it after the fact? Makes it much easier, I think, anyway. All right, right here, no specials right there. We're just going to straight up multiply it. You know what? I'm going to do it with FOIL. So first, it's 35. Outer, 5 times 4x is 20x. Inner, 2x times 7 is plus 14x. And last, that weird little face, right? Which is 2x times 4x, which is plus 8x squared. Now I'm going to put this in order. 8x squared, this goes first, and it's a positive, so 8x squared. Middle terms go next. 20x plus 14x is plus 34x. And then last is plus 35. And in answer to any questions I'm getting, yes, these need to be written in order. That matters. Okay? You wouldn't lose a ton, but you will lose points if it's not in order. All right, this one tells us to factor it. So we're just going to say, what can I take out of it? Whenever it says factor, take what you can. In this case, they don't share any letters, but they do share a number. I can pull a 9 out of each of these. So 9 divided by 9. So when I take a 9 out, I'm just left with u minus, and 27 divided by 9 is 3. There we go. That's fully factored. You can always pause this if you need to. Had a lot of caffeine. Okay, let's go up to the top here. Find the greatest common factors of these three expressions. So first of all, 18, 30, and 42. What can I pull out of an 18, 30, and 42? Let's see, I know I can do a 2. Right? I think I can do a 6 too. Yeah, 6 goes in 18 3 times. So if I took a 6 out, right? So I'm going to write 6 over here just in case I'm wrong. That's what I recommend doing. What am I left with? I'm left with 3, 5, and 42 divided by 6 is 7. Those are prime numbers. Nothing else comes out of them. So I know 6 can come out of it. Then the variables are a little easier. You just pick the one with the lowest degree, right? We have w to the third, w squared, w to the fourth. So they at least all have a w squared in them, right? So I can take w squared, and what does that leave me with? W right here, nothing right there, and w squared here. Yep, there's nothing else I can take out of all three of them. Do you have to simplify them right here? No. It just says to find the greatest common factor. I do it to help me test that I'm doing it right. Okay, let's factor this bad boy. So what can I pull out of a 15 and a 12? Definitely a 3. What can I take out of m cubed and m squared? Well, an m squared, because it's just the lowest degree of m. When I do that, 15 divided by 3 is 5. M cubed divided by m squared is just m. Minus 12 divided by 3 is 4, and the m squared is gone. That's it. Nothing else is factorable here. It says to factor this. I'm looking at it. 3 is not a perfect square, neither is 20, so I'm going to go to the diamond and rectangle, right? 3z squared and minus 20. Down here goes 11z. Up here goes negative 60z squared. And if you don't know what to do, guys, just keep throwing in factors. Like I'm looking at it going, all right, it's not, I know I need one of these to be negative, right? And one of these to be positive. And I need the positive to be bigger so I can get a positive number down here. Let's see, 3 and 20. No, because 20 minus 3 is 17. That's not going to work. See, is there 4 in anything? Yeah, 4 and 15. Wait, 15 minus 4 is 11. So if I have a minus 4 and a positive 15, look at that. Let's do this. I'm going to have 15z. It doesn't really matter which one you put it in. This is how I want to do it. And a minus 4z. Can I pull out of 3z squared and minus 4z? Well, really just z. What can I take out of 15z and negative 20? I can take out a 5. And what times z is 3z squared? Well, 3z. And what times z is negative 4z? Well, that'd just be negative 4. And let's see if it works. Negative 4 times 5 is negative 20. Boom, it works. So I now know that my answer is z plus 5 times 3z minus 4. Nothing else looks factorable. I'm calling that good. All right. This next one, I would say, is one of the more challenging. I'm looking at grouping here. And there's different ways you could look at this, and I don't know if it's always going to work, but let's find out. So if I group it like that, let's take out, what can I take out? I can take out a W. And what am I left with in here? I'm left with 6 plus X. Okay? I think this might just work. Plus, what can I take out of? All right, put parentheses a little too early. What can I take out of 12 and 2? I can take a 2 out. And I'm left with what? 6 plus X. Hey, look at that. That wasn't bad at all. So now they both have a 6 plus X, so I can write this down as 6 plus X times W plus 2. And honestly, that's a great answer. If you want to rearrange it to X plus 6 times W plus 2, that's fine. The only rule is when you flip them, it didn't change anything because they're both positive, but if one was negative, you just need to make sure and carry the negative with it. So yeah, there we go. Either one works. That worked out nice. No stress, right? Okay, factor W squared minus 18W plus 81. I wonder, what's the square root of W squared? It's W. What's the square root of 81? It's 9. Hey, now we got to test it. What's 2 times W times 9? That's 18W. It matches. Therefore, and there's a minus, this is just going to be W minus 9 squared. Look at that. You're welcome to use the generic rectangle and diamond. It will work. I'm going to do this. Looking right here, that's a square. That's not. So we're just going to factor this the OG way. And that's what? X squared, 15, 8x, 15x squared. Let's see. 3 times 5 is 3 plus 5 is 8. So 3x and 5x, right? That's a good one. I didn't really give myself enough room over here, do I? What can I pull out of 3x and 15? 3x times that, right? And then 5 times x, perfect. So this is just x plus 3 times x plus 5. You get fast at these. Right here, these both look like squares, and there's a difference. What do we call that? Difference in squares. Square root of v squared is v. Square root of 4 is 2. So this is just v plus 2 times v minus 2. Now again, if you don't do that and you want to use a generic rectangle, you can always rewrite this as v squared plus 0v minus 4, so that you give yourself that v term and are able to put it in a generic rectangle, which it would go in like this. I want to do it just so you see it, at least the setup. So v squared, the minus 4, and then 0v goes down here, negative 4v squared up here. Okay, then you would finish that, right? All right, our very last one. It says factor completely. It probably means you can pull a common factor out of this. What's common between 5, 40, and 100? Well, 5 is. So this is going to be 5 times what? V squared minus 8v minus 25. And I'm going to go ahead and factor this. Here we're just factoring what's in the parentheses. So we got the v squared, we got the minus 25, minus 8v, multiply minus 25v squared. So we know one's going to be a minus, one's going to be a plus. And I realize as I'm looking at this should be 20. I hope some of you were screaming at the screen, Tim, that's a 20. Hey, I caught it though. That's better. Because, look at this. I know I need to subtract to get negative 8, so the bigger number needs to be negative. Well, how can I get 20? 1 times 20, that won't make negative 8. How about 4 and 5? Nope. That can make negative 9 if they're both negative, but then that would make it positive up here. How about 2 and 10? If I have a negative 10v, right, plus 2v, that'd make negative 8v. So let's do this. I'm going to have 2v, negative 10v, and I can pull a v out. Down here I can pull a 2 out. I know that v times v is v squared. 2 times v is 2v. And then right here, negative 10. And that works. Negative 10 times 2 is negative 20. So this is just, here's how you write the final answer. Don't forget your 5, right? We got to pull that down. Times v plus 2, v minus 10. Boom. Right there. Awesome. With that said, guys, we're done. Get ready. Write a good note card. Crush this test.